Hey, I'm David. I just want to make a quick video here about repairing my Ender 5 3D printer that stopped connecting to my Raspberry Pi Octoprint server. One day it just kind of stopped working, and when I would go into the D-message log of Raspberry Pi, I got a message about device not accepting connections, and it would try over and over again and just never work. I tried many things, different cables, different computers, different operating systems, and nothing seemed to work. I read on the internet about various problems like this, and it didn't work. What I think happened, and to begin with, because it worked, and then I started a print without the printer being turned on, I think that was the problem, because you see this Ender 5, it looks like it's on right now, but it's actually not on if you look at the power switch here. What's happening is part of the control board and the display are being powered by the USB cable. So if I disconnect that, you see the power goes off. But the problem is that this will connect to Raspberry Pi Octoprint. Octoprint will think the printer's on, and I believe if you start the print, what happened is it tried to heat the bed through the USB connection, which obviously there's not enough current. I think it burned out. I started to suspect that it burned out the serial chip. And so I decided, after I ordered a new control board, but in the time it's going to take for that to arrive, I decided I was going to try to repair it. And it turns out that I have some spare Arduino Nano boards that have the same CH340G serial chip on it. So I figured I would harvest one, sacrifice one of my nanos, take the chip from it, and replace it in here. It turned out that it worked. This printer now connects to Octoprint and can make prints. So that was the solution for me. I'll go over now how I did that.
The initial symptom in Octoprint was when it would try to connect, it would give a state of offline and say, error, no more candidates to test and no working port/baud rate combination detected, and just would not connect. I connected to the Raspberry Pi that hosts my Octoprint over a SSH session, and I ran the command D message just so I could see what was happening when the printer was connected, and it said it was connecting to a full-speed USB device number 6 using DWC_OTG, and then it would give an error, device not accepting address 6, error -32. Then it would go through address number 7, device number 8, device number 9, and eventually it would just time out and say device is not accepting address, unable to enumerate USB device. It just would not connect. So as I mentioned, I began to suspect the serial communications chip on the control board of the Ender 5. It's displayed here in this photo up in the, I call it the top, but it's very near the display 10-pin connector next to the USB connector. So that is the chip that I removed, and then I replaced it with one that I harvested from a Arduino Nano board that I had. So if you have an Arduino Nano board, if you look at the top, you have the Atmel main microcontroller chip, and then on the bottom side is this serial chip, the CH340G. This is what translates USB into RS-232 communication so that you can program the Arduino. I decided to remove it, sacrifice this Arduino Nano so that I could try to repair my Ender 5 control board. I took my hot air rework station, I turned the temperature to 390 degrees, and I just blew air all over both sides of the chip. I put my tip of the tweezers underneath one side of the chip, and I lightly pried up on it until it came loose. I did the same on the CH340 chip on my Ender 5 control board, and then I took some flux from my flux pen and rubbed it over the connections. And then I took some solder paste and I just spread it out, not too neatly, over both sides of the pin rows, so that I had what looked like a reasonable amount of solder paste. You don't really have to be too neat with the solder paste, because what I found is that once you heat it up, the flux really kind of pulls it back to the metal pads where it should be. So don't worry about being too neat. Now take the replacement chip that you're going to use and place it on the board. Make sure you get the pin 1 lined up with the dot on the chip and the dot on the board on the same side. And just line up each pin leg with each pad. You don't have to be too perfect, because what happens is the surface tension of the hot solder, once it melts, will kind of pull the chip into the correct place. It works pretty well, but get it as close as you can. Then I got my hot air gun again, and with the temperature set at 390, and the air pressure set at about 6 out of 8, and then I oriented the nozzle to be basically blowing down instead of across the board so that I wouldn't blow the chip away. I just heated up the solder, and you see it melts and kind of pulls the chip back into its place, and I did it basically until it looked like I had it nicely melted and everything looked good. Next, I took the repaired board, I reinstalled it back into my Ender 5, connected all the cables. I turned it on and connected it to the Octoprint cable and tried to connect, and it managed to connect. After that, I tried a print like normal from Octoprint, and everything was good. So apparently the serial interface chip got burned out somehow on my board, and the symptoms were that it just wouldn't connect to Octoprint. So hopefully this helps somebody figure out what was happening with your board. You can either order a replacement control board, or you can do this repair with any WCH. I believe it's a 16-pin dip. An FTDI chip might have the same pin out, but these CH340s are very common. So good luck, and hope everything works out well for you.